Hey guys, welcome to another installment of AP Statistics. I wanted to follow up on last week's talk about two-sample t-tests, which are also known as the independent samples t-tests. There were a couple of questions in MyMathLab that were asking about that question of independence and what to do if not independent, and so I needed to follow up a little. So the moral of the story is just because there are two lists does not mean that it's a two-sample t-test. In this case, we have an app developer who claims that memory can be improved, so they recruit 12 people, and we have pre-test and post-test scores. And the question is, did they improve? This is actually not a two-sample t-test because the data are paired, so we call this a paired t-test. These are actually the same 12 people measured both pre and post test. So the individuals, the 12 individuals, are not independent of each other. This is pretty common when you are looking at matched pairs designs, where you have the same person going through two different treatments, but they're definitely not independent. So the upshot is we want to try and not do a two-sample t-test. We want to do a regular old t-test, a plain old regular one-sample t-test. So the first thing I'm going to do is I'm going to go on over here to my calculator. I'm actually only interested in that amount of improvement. So you can type in all the numbers in L1 and L2. Sometimes that's all that they give you on the AP exam and leave you to do the subtraction. In this problem, they actually give us the amount of improvement. So that's really the only thing that I'm after. And the question is, how much improvement was there on average? The 1var stats tells me that the mean is 0.375, which is not a lot, right? Just like 3 or 4 tenths of an improvement point. So is that significant or not? So here we go. We're going to write our hypothesis. My null hypothesis is that the mean amount of improvement is 0, that there is no improvement. And the alternative hypothesis is that the mean amount of improvement is bigger than 0. Because I'm defining this new variable, I need to define it as the mean amount of improvement, mu sub imp. Then I'm going to check my conditions, but it's the same conditions that you were checking back with the one-sample t procedures earlier a few weeks ago. You either need a simple random sample or you need a random assignment into treatment groups. That will be the thing that shows up when you do matched pairs designs. But in this case, I think it pretty clearly says that there were there was one random sample. We need to evaluate normality, and in this situation, I have the raw data, and because I only have 12 values, I only have 12 individuals, 12 improvements to look at, that's less than 30, so I have to actually draw a plot of those improvements and argue that they are normally distributed. So the easiest way to do that is go into my calculator. So I'm going to go and turn on a box plot of those improvements, which were in L3, zoom 9 it, and there I get a box plot. It's interesting to notice that the y-axis is actually visible here because actually some of those improvements were actually negative, which meant that the people they did the app to improve their memory, and their memory actually got worse. But the upshot here is that I'm looking at that box plot and I'm saying maybe there's a little bit of skew there. If you look at like the medians, pretty much like right between the low and the upper bounds, there might be a little bit of skew, but there's no outliers and it's reasonably symmetric. So we're going to go ahead and proceed with the test, T procedures being robust and all. I figured you guys might fight me on that a little bit, so just to convince you that it's normal, I'm doing a normal probability plot over there too. And the idea is if you see a straight line of the data points versus their standardized values, then it's justified in arguing normality. The third condition is that the population has to be bigger than 10 times the sample, as always. Are there at least, 12 times 10, 100, are there at least 120 people that could have done this app to try and improve their memory? Of course there is. So it's the same 3 conditions for a normal one-sample t-test, but the one sample is just the sample of differences. So we hop over here to our calculations. I'm going to calculate my t-test statistic. It's just one sample, so I'm just going to take my mean, subtract 0, divide by the variance, square root of the variance over the sample size. Let me do all this in my calculator. So I'm going over here to Stat, Calc, and t-test, and set up everything, and there we go. I got my t-test statistic of 3.539. My p-value is apparently 0.002. The calculator doesn't tell you, but this is from 11 degrees of freedom, which is just like the number of differences, which is 12 minus 1. I noticed that the mean standard deviation were also not on my paper anywhere. They were given to me by the calculator, so I'm going to make sure that I'm writing down that value as well. A p-value of 0.002 means that I get to reject the null hypothesis. So my conclusion is going to say, because the p-value is lower than an alpha of 0.05, we reject the null hypothesis. And what does that mean? In context, that means that the app seems to significantly improve the amount of memory. And there you go. That's a complete hypothesis test. Alright, so for the second half of this video, I want to talk about the review plan for the AP exam. We have 3 weeks to go until the actual exam, and the entire course is actually broken up into 4 topics. Topic 1 is describing data. That's where you get normal distribution, standard deviation, regression, all of that kind of stuff. Topic 2 is experimental design. Topic 3 is probability. And topic 4 is inference, which is what we've been working on for the past couple of weeks. Just as a reminder, you should put it on your calendar, that the exam is on Friday, May 22nd, and you need to be ready to roll at 1:30 p.m. The exam actually is going to start at 2 o'clock, but they're suggesting that everybody be ready to roll, trying to log in and get access at 1:30. You guys are going to actually stay in inference. This inference is going to be the first thing that we're going to review. There are actually 2 quizzes this week. The first quiz is just multiple choice. You're going to have to select the correct inference procedure out of the ones that we've talked about. The second quiz is 2 free response questions that I want you to try and fully submit as if they were the real deal on the real exam. Hope everything is going well, and I will talk to you guys soon.